All right, this video is a review of chemical formulas. So the first thing that I'd like to start off with is just actually showing you how to write formulas. So the first one, this is that flow chart that I gave you guys. I'll also attach it with this post on how to decide which naming convention to use. So it's going to start here with do you see any prefixes in the name? And so by prefixes, I mean di or tri or something along those lines, or tetra. So in this case, I don't see any prefixes, so the answer is no. So it's either an acid or an ionic bond. When I read this, it's pretty obviously that it is not an acid. So we're going to go with ionic. We need to use the charges, and then we are going to crisscross those charges. So calcium is Ca, and it's located in group 2 of the periodic table. That means when it becomes an ion, it likes to have a 2 positive charge. Nitride, if it ends in IDE, that means it ends in an element. So this is nitrogen. Nitrogen's in group 15, and it likes to be at a charge of 3 negative when it becomes an ion. The sum of these charges or oxidation numbers does not equal 0. So that means that I need to crisscross. I've got to add some subscripts. So we don't cross signs and we don't cross ones. Here we're actually going to have a true crisscross. So 3 and then N2. Now, if I had something like calcium oxide, calcium's in group 2, so it likes to be at 2 positive. Oxygen's in group 16, and it likes to be at 2 negative. That means that calcium wants to give up 2 electrons and oxygen wants to gain 2 electrons. So there is an even exchange of electrons. We don't have to get any more calcium or oxygen atoms involved. It's just going to be CaO. So if the oxidation numbers are the same, then you don't crisscross them. You just rewrite them again without their charges. Okay, so now let's look at some that are a little more advanced. So I've got some here that involve some polyatomic ions. So let's look at this one right here, copper 2 sulfate. So copper is Cu. It is a transition metal. So we don't know its charge. It could be 2, it could be 1. But the Roman numeral tells us the charge of copper, and it tells us that it's going to be copper 2. So it has a 2 positive charge. And then sulfate, if it ends in IDE, it's an element. If it doesn't end in IDE, it is more than likely a polyatomic ion. And you have a list of those in your reference tables. So here's sulfate, SO4 2 negative. And the sum of the charges is equal to 0. So this is just going to be CuSO4. Now, if we had something like this next one, sodium carbonate, sodium's in group 1, so it likes to be at 1 positive. Carbonate is another polyatomic ion, and carbonate is right here, CO3 2 negative. So the sum of the charges is not 0, so we have to crisscross. We don't cross signs and we don't cross 1, so the only thing that's going to move is this 2. And so the formula for this would be Na2CO3. Now, all of those were ionic bonds, both with just elements and with polyatomic ions. So now let's try something a little different. Let's look at this one, number 7. Carbon tetrachloride. So we go back up to the top on our flow chart and say, do we see prefixes in the name? Well, yeah, I see tetra right here. So that means it's covalent. We write down exactly what the name says using symbols. So no charges, no crisscrossing. This is a molecule. It's not made of ions. So we have 1 carbon, and then we're going to have that bonded to chlorine, and tetra means 4. So that is the formula for carbon tetrachloride. Let's look at this one. All right, so number 8 there is an acid. So we don't see prefixes in the name. It is an acid because it says so in the name. So does it start with hydro? Well, in this case, it does not. So that means it is hydrogen and a polyatomic ion. We've got to use the charges and crisscross. All right, so that means we have hydrogen, because all acids start with hydrogen, and hydrogen's in group 1, so it likes to be at 1 positive. Well, we know that this is a polyatomic ion that this hydrogen is bonded to. Ic came from 8, so this is sulfate again. We could look that up on our reference tables, but it's SO4 2 negative. The sum of the charges is not 0, so we have to crisscross. So that 2 is the only thing that's going to move, and it's H2SO4. Okay, so what about if we're going the other way? What if we have a formula and want to name it? Well, we have a flow chart for that as well. And for that one, let's look at, let's do this one here. All right, so what does the formula start with? And that's your key here on knowing how to name it. So it doesn't start with a hydrogen. Calcium, yeah, is a metal. So that's the one I'm going to go with here. That means I have ionic bonds. You're not going to use prefixes. You might have to use Roman numerals to indicate the charges of transition metals. Calcium is not a transition metal. It's in group 2, so we don't have to use Roman numerals for this one. All right, so we are going to just name the 2 things. So we've got calcium, and then this is a polyatomic ion, and that polyatomic ion is hydroxide. So calcium hydroxide. Now, if it were something that ended in an element, so this is easy when it has a metal and then a polyatomic ion, you don't have to worry about changing the ending. But if it were something like, if I had MgS, well, this starts with a metal, so we know it's ionic. So we're going to name the first guy magnesium. And then the second one is sulfur, so we're going to write sulfide. If it ends in element, it's going to end in IDE. All right, so now let's look at a different one. Let's try this one right here, number 13. So what does the formula start with? Well, this one starts with phosphorus, which is a non-metal. So that means we have covalent bonds, so we're going to use prefixes. So for this one, the prefix for 3 is triphosphorus. And then the prefix for 6 is hex, and then it's chloride. So triphosphorus hexachloride for that particular one. Because it started with a nonmetal, it's a molecule. All right, and now let's look at this last one right here, number 16. It starts with a hydrogen, so we know it's an acid. Is it hydrogen and polyatomic ion or hydrogen and element? Well, that's the one we want to choose here. And so it's going to start with hydro, the root of the second element's name, and then ic, acid. So hydro, the second element is fluorine, so this is fluor, and then fluoric, and then acid. Okay, so that's a quick rundown on how to name a lot of these. Let me do this other acid that I see up here. Let's do this one, and then we'll be finished with the naming practice. So this does start with hydrogen, so it is an acid, but this time it's hydrogen and a polyatomic ion. No hydro, adic, us. So we need to name the polyatomic ion. So NO3 is right here. It is nitrate. So nitrate, which means the 8 is going to change to ic. So nitric, and then we write the word acid.